Right now, we have not yet compiled this program we created in the last lecture, so I don't even know if it's good. We're about to find out. And we're definitely out of sync with our simulator, so let's start by just running it. Yep, it compiles. Load it. Good. We haven't made any mistakes. We are online and we are up and running. Perfect. So we are going to start. We can see that everything is disengaged. We don't have any of our inputs coming into our counters doing anything. And we can see our count values here. We've got 0, we've got 0, we've got 0. Now this QD right here, you can see that this is true. That's not a value. Just like this QU, we can see this one is already true even though the rest of our counts are open. This one, our count down is true, our count up is false, and this one is false as well. So why are those true and false? Well, before we start actuating these counters and counting things, let's stop and figure out where we are. For our count up, okay, right now we have a count value of 0 and we're trying to count up to 5. Therefore, we're not at 5 yet, so this Q is disabled. Now look here. We are going to start at 5. And this is a count down timer. We want to count down to 0. So why are we already energized? Well, we're at 0 already. So until we load this counter, it's not going to be counting down. It's going to start off energized because it starts off at 0 rather than starting off at its preset value. Okay, that's something interesting to keep in mind. And then when we look at our count up, count down, this count down right here, this QD, this down output, that's going to be true anytime our count value, because this thing can be positive or negative. Anytime we're at 0 or below 0, this QD is going to be energized. This QU is only going to be energized when we get up to our PV. Right now, our count value is 0. So QD is true, but since we are not at 5 yet, our QU is false. Okay? So let's go through here and we're going to just energize our input 1 one time, and that is for counting up. So for the CTU and the CTUD, we would expect our count value to go up to 1. So let's go ahead and try that now. Modify to 1. Modify to 0. Okay, we've got a 1 on our count up. We didn't do anything with our count down, so that's still at 0. And our count up down, sure enough, is at 1 as well. All right, that's pretty easy. Let's do a count down, and that's input 2. So the first thing we do, if we try doing a count down here, modify to 1, you see what happened is we went into negative. Modify to 0. Okay, we don't really want that. Remember, the goal is to try to get to 0. So the first thing that we're going to do is we're going to have to load this counter, all right? So watch what happens when I toggle this. Modify to 1, and instantly this goes all the way up. It sets the count at the preset value. So let's modify that back to 0. Now, when I try to count down, now it's counting down. Now it went from 5 to 4. Okay, so that's what we want it to happen. But remember, we had to essentially initialize this counter first by loading it out. And when we come over here, because we loaded it out, we're using the same variable, the same tag load there and here. So we also loaded this one up to 5 and brought it down to 4 as well. So we've got an idea now. This can count up, this can count down. We know what load does. Now let's check our reset, okay? So we've counted up to 1. When we modify our reset to 1, it resets everything back to 0. So we're at 0 here, we don't have a reset on this. We only have a load. So we don't ever want to set a count down to 0. We always want to set that back up to the top. And then we do have a reset here, so we've gone back to 0. Okay. Now let's go ahead and see what happens when we expire these counters. So modify to 1, modify back to 0. We've counted up to 1. Modify to 1, modify to 0. We're at 2, 1, 0, 3, 1, isn't this exciting? 0, 4, and finally we've counted up to 5 and we've energized our output. And if we modify to 0 and go to 1 again, look at that. We've got our count down, and I think we already know how that's going to work. So, if we modify our countdown value back and forth, we're going to get that back down to 0, and then when we do, this is going to energize. So I don't think I'm going to make you sit here and watch me toggle that back and forth 3 more times. And for our count up, count down, when we loaded this counter, up to 5, you can see we energized our output for counting up. And now, since we're not at 0 anymore, we've de-energized our output for counting down. We know how the resets work, we know how the loads work, and we know how it counts the things coming in. Something else that I want to mention and just remind you of, really, that on some other platforms, if we leave this thing energized like this all the time, this is going to count, this counter is going to count every single scan. So that value is going to go up 5, 10, 20, 30, something like that every second while this is energized. And for things like that, you're going to have a one-shot before your counter or before, whatever's energizing this contact. In Siemens, the counter, basically, you can think of it as having a one-shot built inside. So like a positive trigger built inside. It's going to count when this condition transitions from false to true. But once it's already true, and this keeps scanning over and over again, the counter is not going to keep counting, okay? So that's something, a very important distinction to keep in mind with Siemens counters versus the counters in some other environments. If you just set up your counters like this in other environments, you're going to get yourself in trouble very quickly.